In this presentation, we are going to explore security and system design. We will cover topics such as authentication, authorization, and security best practices. By the end of this video, you will have a solid understanding of how to build secure and resilient systems. Let's begin with the fundamentals of security. Security is primarily built on two main pillars: authentication and authorization. Authentication is all about verifying the identity of a user. Basically, it answers the question, "Who are you?" It ensures that the user is who they claim to be. Authorization, on the other hand, determines what a user can access or do within the system. It answers the question, "What can you do?" and involves controlling access rights based on the user's identity and role. There are various methods for authenticating users. The first and most traditional method is using a username and password, where users provide their credentials to gain access. Then we have multi-factor authentication, which enhances security by requiring multiple verification factors, like a password and a code sent to your phone. Next is the token-based authentication, such as Java Web Tokens or OAuth, which provide a stateless way to authenticate users. Finally, there is biometric authentication, which uses unique biological traits like fingerprint, facial recognition, or voice authentication to verify identity. Now let's examine a practical example of JSON Web Token, or JWT authentication. Here is a Python code snippet showing how a JSON Web Token is created. First, we import the necessary modules. Then we define a function called createToken, which takes a user ID as input. Inside the function, we create a payload containing the user ID and an expiration time for the token, typically set to 24 hours from the current time. Finally, we encode the payload using a secret key and the HS256 algorithm, generating the JSON Web Token. This token can then be used to authenticate subsequent requests from the user. Moving on to authorization models, two popular approaches are role-based access control and attribute-based access control. Role-based access control, or RBAC, assigns permissions based on the roles a user has within an organization, such as administrator, user, or guest. Attribute-based access control, or ABAC, evaluates access based on various attributes, enabling more dynamic and context-aware authorization policies. Here's a code example demonstrating role-based access control, or RBAC implementation using decorators. The require role decorator checks if the user has the necessary role before allowing access to a function. For example, only administrators or managers can delete users. Similarly, the require permission decorator verifies if the user has the required permission, like read reports, before granting access to a function, such as get analytics. This approach simplifies authorization logic and enhances code readability. To build secure systems, we should adhere to several best practices. Firstly, it is important to sanitize and validate all user inputs to prevent injection attacks. Secondly, encrypt sensitive data both when it is stored and when it is being transmitted. Thirdly, implement rate limiting to prevent abuse and distributed denial of service, or DDoS attacks. Lastly, it is crucial to use Hypertext Transfer Protocol Secure, or HTTPS, Cross-Origin Resource Sharing, or CORS, Content Security Policy, or CSP, and other security headers properly to protect against various threats. Now, let's shift our focus to Secure Application Programming Interface, or API design. The code example showcases how to implement API security measures. The Validate API Key function verifies the validity of the API key sent in the request headers before processing any requests. Additionally, the rate limit decorator limits the number of requests a user can make within a certain time frame, such as 100 requests per hour. This helps protect against abuse and ensures fair usage of the API. Awareness of common security vulnerabilities is crucial for building robust systems. One such vulnerability is structured query language, or SQL injection, which involves executing malicious SQL code through unvalidated inputs. Another common threat is cross-site scripting or XSS attacks, which occur when malicious client-side code is injected into web pages. Lastly, data exposure refers to the unintended disclosure of sensitive information due to misconfigurations or vulnerabilities. To ensure comprehensive security, follow this implementation checklist. First, implement authentication and authorization mechanisms to control access to resources. Next, validate and sanitize all user inputs to prevent injection attacks. Use Hypertext Transfer Protocol Secure, or HTTPS, and security headers to protect against various threats. Encrypt sensitive data both at rest and in transit. Implement rate limiting to prevent abuse. Finally, conduct regular security audits and testing to identify and address potential vulnerabilities. Build secure, scalable systems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.